Have you ever wondered where the very first ingredients of existence came from? Picture this. 13.8 billion years ago, there was nothing. No stars, no planets, no elements. Just an infinitely hot, dense point smaller than the period at the end of this sentence. Then, in a fraction of a second, everything changed. The Big Bang wasn't just an explosion. It was the universe's first kitchen, and it was cooking at temperatures so extreme that they make the core of our sun look like a freezer. In those first few minutes, the entire cosmos was like a giant pressure cooker, with temperatures reaching 10 billion degrees Celsius. At these incredible temperatures, the most basic building blocks of matter, protons and neutrons, were crashing into each other with such force that they actually stuck together. But here's the fascinating part. This cosmic kitchen could only make the simplest recipes. The universe was expanding and cooling so rapidly that it had just a narrow window of time to create elements. In those crucial first 20 minutes, it managed to forge hydrogen, the simplest element with just one proton, and helium, with 2 protons. The universe also created tiny amounts of lithium. But then something remarkable happened. The temperature dropped too low, and the cosmic cooking stopped. Imagine, if you will, the entire universe suddenly going quiet. No more fusion, no more element creation. For the next few 100 million years, the cosmos entered what astronomers call the Dark Ages, a period where no stars had formed yet, and the universe was filled with nothing but hydrogen and helium gas floating in the darkness. This is one of the most incredible facts about our universe. Even today, after billions of years of stellar evolution, 75% of all normal matter is still hydrogen, and 25% is helium. Everything else, the carbon in your body, the oxygen you breathe, the iron in your blood, makes up less than 2% of the universe. We are literally made from cosmic rarities. But the Big Bang's simple recipe would turn out to be perfect. Those hydrogen and helium atoms were like seeds waiting to grow into something magnificent. Little did the universe know that these humble beginnings would eventually lead to the creation of every element on the periodic table, forged in the hearts of stars that hadn't even been born yet. The stage was set for the next chapter of our cosmic story, where gravity would gather these primordial elements into the first stellar nurseries, and the real alchemy of the universe would begin. Picture this. 13.8 billion years ago, everything that exists today was compressed into a space smaller than the tip of a needle. Then, in an instant that changed everything, the universe exploded into existence with a burst of pure energy so intense that it's almost impossible to imagine. But here's where it gets really wild. This wasn't just any explosion. In those first precious minutes, the entire universe was like a cosmic pressure cooker running at temperatures of 10 billion degrees. That's about 600 times hotter than the core of our sun. At these mind-bending temperatures, the fundamental particles of matter were moving so fast and colliding so violently that something magical happened. They started sticking together. Protons and neutrons, the basic building blocks of atomic nuclei, were slamming into each other with such incredible force that they fused together. It was like the universe's very first chemistry experiment. But instead of happening in a lab, it was happening everywhere at once. This cosmic kitchen was working at lightning speed, creating the simplest elements in the periodic table. First came hydrogen, just one proton, the universe's most basic recipe. Then came helium, with 2 protons bound together. The universe even managed to cook up tiny amounts of lithium, with 3 protons. But here's the catch. This incredible cooking spree lasted only about 20 minutes. As the universe expanded, it cooled down rapidly, and the temperatures dropped too low for any more nuclear fusion to occur. When the cosmic oven finally cooled down, the universe had created a very specific recipe: 75% hydrogen, 25% helium, and just trace amounts of lithium. That was it. No carbon, no oxygen, no iron. None of the elements that would later become essential for planets and life. Now here's something that might blow your mind. Even after billions of years of stars being born, living, and dying, 98% of all the visible matter in the universe is still that original hydrogen and helium from the Big Bang. Think about that for a moment. You're looking at the universe's baby photos every time you see a hydrogen atom. This means that all the other elements we see around us, The carbon in our bodies, the oxygen we breathe, the gold in our jewelry, they make up less than 2% of everything we can see in the cosmos. We're literally made from the universe's rarest ingredients, created in processes that wouldn't begin for hundreds of millions of years after that first cosmic cooking session. The Big Bang had set the stage perfectly, creating the raw materials that would eventually become the fuel for the first stars. Those simple hydrogen and helium atoms were like seeds, waiting patiently in the darkness for gravity to gather them together and create the stellar furnaces that would forge all the other elements we know today. After the Big Bang's brief cooking session ended, the universe entered what we might call its awkward teenage years. For hundreds of millions of years, space was filled with nothing but clouds of hydrogen and helium drifting in the cosmic darkness. But gravity, that persistent force that never gives up, was quietly at work, pulling these gas clouds together bit by bit. Imagine a slow-motion dance happening across the cosmos. These vast clouds of gas, some stretching across light years, began to collapse under their own weight. As they shrank, something incredible started to happen. They got hotter and denser, like squeezing a sponge tighter and tighter. The center of these collapsing clouds became furnaces, waiting to ignite. Here's where the magic really begins. When the core temperature reached 10 million degrees Celsius, something extraordinary happened. The hydrogen atoms at the center were moving so fast and being squeezed so hard that they overcame their natural tendency to repel each other. 4 hydrogen nuclei crashed together with such force that they fused into one helium nucleus, and in that moment, the first star was born. Think of a star like the ultimate cosmic pressure cooker. The gravity trying to crush everything inward creates pressures that are millions of times greater than anything we can imagine on Earth. At the same time, the nuclear fusion happening at the core pushes outward with tremendous force. It's a perfect balance. Gravity says collapse, while fusion says expand, and the star sits right in the middle, burning steadily for billions of years. But here's what's truly mind-blowing about this process. Every time 4 hydrogen atoms fuse into one helium atom, a tiny bit of matter gets converted into pure energy. That energy travels from the star's core, through thousands of miles of stellar material, and eventually reaches the surface as light and heat. The sunlight warming your face right now began its journey as nuclear fusion in the sun's core, and it took over 100,000 years just to travel from the center to the surface. Now, here's where stars get really interesting as cosmic chefs. A star's cooking ability depends entirely on its size. Small stars, like red dwarfs, are like gentle, slow cookers. They burn their hydrogen fuel so slowly that they can keep going for trillions of years. Our sun is like a medium-sized oven, burning through its fuel at a steady pace and expected to keep shining for another 5 billion years. But massive stars, those with 10, 20, or even 50 times the mass of our sun, these are the high-pressure industrial kitchens of the universe. They burn so hot and so fast that they can cook up elements far beyond simple helium. The incredible pressure and temperature in their cores can fuse helium into carbon, carbon into oxygen, and oxygen into even heavier elements. Here's something that might surprise you. The energy from nuclear fusion is so efficient that the sun converts only 4 million tons of matter into energy every single second. That sounds like a lot, but considering the sun weighs about 2 billion trillion tons, it's barely noticeable. The sun has been doing this for 4.5 billion years and has only lost about 1/10,000th of its total mass. Every star that lights up the night sky is essentially a nuclear power plant that's been running for millions or billions of years, converting the simplest element in the universe into slightly more complex ones and releasing the energy that makes life possible. Without stellar fusion, the universe would still be a cold, dark place, filled with nothing but hydrogen and helium. The birth of the first stars marked the end of the cosmic dark ages and the beginning of the universe's greatest cooking adventure, one that would eventually create every element needed for planets, and ultimately, for us. Every star has a story, and like all good stories, they have a beginning, a middle, and an end. Stars, like our sun, live what we might call comfortable lives. They spend about 10 billion years happily fusing hydrogen into helium in their cores, shining steadily and warming any planets that might be orbiting them. But even the most stable stars eventually face a crisis that changes everything. Picture our sun 4.5 billion years from now. After burning through the hydrogen in its core for nearly 10 billion years, it suddenly finds itself in trouble. The fuel that has kept it shining all this time is running out at the center, and the star faces its first major life decision. Without hydrogen fusion to push outward against gravity's relentless pull, the core starts to contract and heat up dramatically. Here's where things get interesting. As the core gets hotter and denser, it eventually reaches temperatures of 100 million degrees, 10 times hotter than it was before. At these extreme temperatures, helium nuclei start crashing into each other and fusing together. 3 helium nuclei combine to create carbon, and when carbon fuses with another helium nucleus, it creates oxygen. The star has learned to cook with new ingredients. But this helium burning phase is like living on borrowed time. While hydrogen fusion can keep a star going for billions of years, helium fusion burns much faster and hotter. The star swells up to enormous proportions, becoming what we call a red giant. If our sun did this today, it would expand so much that it would swallow up Mercury, Venus, and possibly even Earth. Now, stars like our sun can only go so far in this cosmic cooking game. After creating carbon and oxygen, they simply don't have enough mass to squeeze their cores any tighter or get them any hotter. They eventually shed their outer layers into space, creating beautiful clouds called planetary nebulae, while their cores become white dwarfs, hot, dense remnants about the size of Earth, but with the mass of the sun. But massive stars, those giants with 10, 20, or 50 times the mass of our sun, these are the true master chefs of the universe. They don't stop at carbon and oxygen. They have enough gravitational muscle to keep cranking up the heat and pressure in their cores. These stellar giants live fast and die young. While our sun will burn for 10 billion years, a star 20 times more massive might only live for 10 million years, 1,000 times shorter. But in that brief cosmic lifespan, they create something extraordinary. They build up layers in their cores like a cosmic onion. In the very center, they fuse silicon and other elements into iron. Surrounding that, there's a layer where they're fusing oxygen into silicon and sulfur. Outside that, there's carbon fusion, then helium fusion, and finally, hydrogen fusion in the outermost layer. It's like having 5 different kitchens operating at different temperatures, all stacked on top of each other. But here's where the story takes a dramatic turn, one that determines the fate of the entire star. Iron represents the end of the road for nuclear fusion. Every element lighter than iron releases energy when it fuses together. That's what keeps stars shining. But iron is different. Iron is the most stable nucleus in the universe, which means fusing it with anything else doesn't give you energy back. It actually costs energy. Imagine a star that has spent millions of years as a perfectly balanced nuclear furnace, with fusion energy pushing outward against gravity pulling inward. Suddenly, its core starts filling up with iron, an element that can't provide the energy needed to keep the star inflated. It's like a car running out of gas while going uphill. The core temperature might reach 3 billion degrees, but even that incredible heat can't make iron fusion profitable. As more and more iron accumulates in the core, the star faces an impossible situation. The core becomes like a ball of iron the size of Earth but with more mass than our sun. Gravity is pulling inward with tremendous force, but there's no more fusion energy to push back. The star has painted itself into a nuclear corner, and there's only one way out. The tension builds as iron continues to pile up in the core. The star's days are numbered, and when the iron core reaches a critical mass, about 1.5 times the mass of our sun, something catastrophic is about to happen. The stellar balance that has held for millions of years is about to collapse in the most spectacular way imaginable. This is the cosmic drama that sets the stage for one of the universe's most violent and creative events, an explosion so powerful that it can be seen from billions of light years away, and so transformative that it will scatter the star's hard-earned elements across the galaxy, seeding space with the ingredients for future worlds. What happens next is one of the most dramatic events in the entire cosmos, a stellar death so violent and so spectacular that it transforms everything we thought we knew about how elements are created. Picture this massive star with its iron core, trapped in an impossible situation with nowhere to go. The tension has been building for thousands of years, as iron accumulates in the center, and now the moment of truth has arrived. In less than 1 second, faster than you can blink your eyes, the iron core collapses. We're talking about a ball of matter with more mass than our entire sun, compressed from the size of Earth down to just 12 miles across. The core becomes so dense that a teaspoon of this material would weigh as much as Mount Everest. The collapse is so sudden and so violent that it creates a shockwave that changes the course of cosmic history. But here's where the story gets truly incredible. As this shockwave rips through the star's outer layers, something magical happens. The temperatures and pressures become so extreme that they create conditions even more intense than anything the star experienced during its entire lifetime. In those brief, violent moments, elements that could never be forged in the steady burning of a star's core suddenly come into existence. Gold, silver, platinum, uranium, all the elements heavier than iron that seemed impossible to create. They're all born in this cosmic explosion. The shockwave is like the universe's most powerful particle accelerator, smashing nuclei together with such force that they stick together despite their natural tendency to repel each other. In a matter of seconds, the supernova creates more heavy elements than the star produced in millions of years of normal burning. The explosion is so bright that a single supernova can outshine an entire galaxy containing 100 billion stars. If a supernova happened 25 light-years from Earth, still incredibly far away, it would appear as bright as the sun in our sky. These explosions are so powerful that we can see them from billions of light-years away, across the entire observable universe. But the real magic isn't just in the brightness, it's in what happens next. The explosion hurls all of these newly created elements into space at speeds of thousands of miles per second. Imagine the star's entire life's work. Millions of years of carefully cooking carbon, oxygen, silicon, and iron, plus all those precious heavy elements created in the explosion itself, suddenly being scattered across hundreds of light-years of space. This is where Carl Sagan's famous words ring true. We are made of star stuff. But it's even more poetic than that. We are made of supernova stuff. The iron in your blood was forged in the core of a massive star. But the gold in your jewelry was created in the last violent seconds of that star's life. The calcium in your bones, the oxygen you breathe, the carbon that forms the backbone of every molecule in your body, all of it was once inside a star that lived, died, and gave its life to enrich the universe. Here's something that might give you chills. Every heavy element on Earth, every precious metal, every element essential for life, they all came from stars that exploded before our solar system even existed. When our sun and planets formed 4.5 billion years ago, they were built from a cloud of gas and dust that had been enriched by countless generations of stars that lived and died before us. The timing had to be perfect. The first stars in the universe contained only hydrogen and helium from the Big Bang. They lived, died, and exploded, enriching space with the first heavy elements. Then a second generation of stars formed from this enriched material, creating even more elements and exploding in turn. It took billions of years and countless stellar generations to create enough heavy elements to make rocky planets and complex chemistry possible. Without supernovas, the universe would be a very different place. There would be no rocky planets, no metals, no complex molecules, and certainly no life as we know it. These stellar explosions are literally the universe's way of sharing the wealth, taking the elements created in stellar cores and distributing them throughout the galaxy. Every time you look up at the night sky, you're seeing a universe that has been shaped by these cosmic explosions. The very atoms that make up your body have traveled across space and time, forged in stellar fires and scattered by supernova winds, eventually finding their way to a small, rocky planet where they would become part of something wonderful. A conscious being capable of looking back at the stars and understanding the incredible journey that brought them here. If this kind of cosmic storytelling fascinates you, make sure to subscribe to Exploring the Universe and join us as we continue to uncover the incredible connections between the cosmos and ourselves. There's so much more to discover about how we're all connected to the stars. Just when we thought we had the story of element creation figured out, the universe surprised us with one more incredible plot twist. For decades, scientists knew that supernovas could create heavy elements like gold, But there was always something puzzling about the math. When we looked at how much gold actually exists in the universe, supernovas alone couldn't account for all of it. There had to be another cosmic goldsmith at work, and in 2017, we finally caught it in the act. Picture this. Somewhere in a galaxy 130 million light-years away, two incredibly dense objects are locked in a deadly dance. These aren't ordinary stars. They're neutron stars, the crushed cores left behind after massive stars exploded as supernovas. Each one is only about 12 miles across, roughly the size of Manhattan, but packed with more mass than our entire sun. They're so dense that a sugar cube of neutron star material would weigh as much as Mount Everest. These two neutron stars have been orbiting each other for millions of years, slowly spiraling inward as they lose energy. It's like a cosmic ballet performed by the universe's most extreme objects. But this dance has only one possible ending, and as the two stars get closer and closer, the tension builds to an incredible crescendo. When neutron stars finally collide, what happens next is almost beyond imagination. In a fraction of a second, these two ultra-dense objects crash into each other at speeds of thousands of miles per second. The collision is so violent that it sends ripples through space-time itself, gravitational waves that we can detect here on Earth with incredibly sensitive instruments. But here's the truly amazing part. In those brief moments of collision, the extreme conditions create a cosmic treasure factory, unlike anything else in the universe. The neutrons from both stars are squeezed and heated to such incredible temperatures and pressures that they start sticking to existing atomic nuclei faster than the nuclei can decay. This process, called rapid neutron capture, can create elements far heavier than iron in just seconds. A single neutron star collision can produce several hundred times the mass of Earth in pure gold. That's more gold than a massive star could create in its entire lifetime, all manufactured in the blink of an eye. But it doesn't stop at gold. These collisions also create platinum, silver, and other precious metals that we treasure here on Earth. Here's something that might completely change how you look at jewelry. Scientists estimate that neutron star collisions are responsible for creating most of the gold in the universe. That wedding ring on your finger, that gold necklace, those precious metal components in your smartphone, they were all likely forged in one of these incredibly rare and violent cosmic events. Think about the journey that gold took to reach you. Billions of years ago, in a galaxy far away, two neutron stars completed their final dance of destruction. The collision scattered newly created gold atoms into space, where they drifted for millions of years through interstellar clouds. Eventually, these atoms became part of the gas and dust cloud that collapsed to form our solar system. They were incorporated into the early Earth, and through billions of years of geological processes, they eventually ended up concentrated in veins of ore that humans would one day discover and mine. The rarity of gold on Earth actually reflects the rarity of these cosmic events. Neutron star collisions are incredibly uncommon. They might happen only once every 100,000 years in a galaxy like ours. That's why gold is so precious. Every gold atom on Earth is a survivor of one of the universe's most extreme events, making the journey across space and time to end up in our planet's crust. But here's what makes this discovery even more remarkable. We're living in the first generation of humans to actually witness one of these events as it happened. In August of 2017, gravitational wave detectors picked up the signal of two neutron stars colliding, and for the first time ever, telescopes around the world turned to watch the aftermath. They saw exactly what scientists had predicted, a brilliant flash of light rich in the signatures of newly created heavy elements. This wasn't just an abstract scientific discovery. We were literally watching the universe create the elements that make up our technology, our jewelry, and even essential components of our own bodies. The collision produced so much gold that if you could somehow collect it all, it would be worth more than all the wealth that has ever existed on Earth. The next time you hold something made of gold, take a moment to appreciate its incredible origin story. That simple metal has traveled farther and experienced more extreme conditions than anything else you'll ever touch. It was born in violence, scattered through space, collected by gravity, processed by geology, and finally shaped by human hands into something beautiful. In a very real sense, we're not just made of star stuff, we're made of the rarest star stuff, created in events so uncommon and so violent that they represent some of the most dramatic moments in cosmic history. The universe had to destroy some of its most exotic objects just to create the elements that make our modern world possible. As we reach the end of this incredible journey through time and space, let's take a moment to truly appreciate what we've discovered. From the first moments after the Big Bang, when the universe was nothing but hydrogen and helium floating in the darkness, to the violent collisions of neutron stars creating gold in flashes of unimaginable energy, every single atom in your body carries with it an epic story that spans billions of years. Think about this for a moment. The hydrogen in the water you drink was created in the first 20 minutes after the Big Bang. Those atoms are 13.8 billion years old, and they've been waiting all this time to become part of you. The carbon that forms the backbone of your DNA was forged in the core of a star that burned for millions of years before giving its life in a supernova explosion. The iron flowing through your veins right now was created in the final moments of a massive star's life, in temperatures so extreme they dwarf anything we can imagine. But perhaps the most remarkable elements in your body are the heavy ones, the trace amounts of gold, silver, and other precious metals that are essential for your nervous system to function. These atoms were born in the most violent events the universe has ever known. The collision of neutron stars so dense that a teaspoon would weigh as much as a mountain. These cosmic catastrophes happened billions of years ago, in galaxies far away, and yet their products found their way here to become part of something beautiful. You. Here's what makes this story even more incredible. We are not just made of star stuff. We are the universe becoming aware of itself. For 13.8 billion years, the cosmos has been evolving, creating increasingly complex structures, from simple hydrogen atoms to massive stars, from exploding supernovas to swirling galaxies, from rocky planets to living organisms, and finally to conscious beings capable of looking back at the stars and understanding their own origins. Every time you look up at the night sky, you're witnessing a family reunion of sorts. Those distant stars are your cosmic relatives. They're made of the same fundamental particles that make up your body, forged in the same nuclear furnaces, scattered by the same explosive events. The light from those stars has traveled across the universe to reach your eyes, connecting you directly to the ongoing story of cosmic evolution. But there's something even more profound happening here. When you gaze at the stars and feel that sense of wonder, that's literally the universe looking at itself and marveling at its own beauty. The atoms in your brain that fire when you contemplate the cosmos are the same atoms that were once inside ancient stars. The universe has spent billions of years creating the conditions necessary for matter to organize itself into something capable of consciousness, wonder, and understanding. This means that every moment of curiosity you feel about space, every time you're amazed by a sunset or moved by the sight of the Milky Way, you're participating in the universe's greatest achievement, the development of self-awareness. You are not separate from the cosmos. You are how the cosmos experiences itself. The next time you look at your hands, remember that you're looking at recycled stardust that has been on an incredible journey. The calcium in your bones was created in stellar furnaces. The oxygen you breathe was forged in the hearts of massive stars. The gold in your electronics was born in neutron star collisions that sent shockwaves across space and time. And perhaps most amazing of all, the atoms that make up your brain, the very particles that allow you to think these thoughts and feel this sense of wonder. They've been part of this cosmic story from the very beginning. They've been inside stars, scattered through space, incorporated into planets, and now they're part of you, continuing their journey through the universe. We are all walking collections of cosmic history, temporary arrangements of ancient particles that have come together for a brief moment in cosmic time to experience the universe from the inside. Every breath you take connects you to every star that has ever lived and died, every supernova that has ever exploded, every neutron star collision that has ever occurred. The stars are not just out there in the distant sky. They are within you, part of your very essence. You are not just observing the universe. You are the universe observing itself, thinking about itself, and marveling at the incredible journey that brought us all here. So the next time you step outside on a clear night and look up at the stars, remember that you're not looking at something foreign and distant. You're looking at your origins, your family, your true home. The stars are not just out there. They are part of you, and you are part of them, in the most literal and beautiful way possible. If this cosmic perspective fills you with the same sense of wonder that it brings to us, make sure to subscribe to Exploring the Universe, hit that notification bell, and share this incredible story with friends who love to contemplate our place in the cosmos. Together, we'll keep exploring the amazing connections between ourselves and the universe that made us. See you on our next stellar journey.